Welcome to this video on the fundamentals of electric and hybrid vehicles, brought to you by ProTech Academy. In this video, we will explore key concepts, including vehicle types, core components, drivetrain systems, and safety considerations for EVs and hybrids. Let's begin with Chapter 1. What exactly is an electric vehicle? An electric vehicle, or EV, uses an electric motor and battery for propulsion, reducing or eliminating reliance on a traditional internal combustion engine. This diagram highlights the core components of an electric car, including the traction motor, battery pack, inverter, and charging system. A closer look at the electric powertrain reveals the specialized components that drive modern electric vehicles. The vehicle architecture is specifically designed to house these high-voltage systems efficiently. Here we see the integration of the drivetrain and high-voltage cabling within the vehicle chassis. Comparing an internal combustion engine to an electric powertrain highlights the significant reduction in moving parts. Hybrid setups offer a different approach, combining traditional engines with electric motor systems. This integrated drive unit combines multiple functions, including power distribution and the DC-to-DC converter, alongside the drive motor. Moving on to Chapter 2, we will now break down the different types of electric vehicles. There are four main categories: battery electric vehicles, hybrid electric vehicles, plug-in hybrids, and fuel cell electric vehicles. This diagram illustrates the flow and energy sources for each of these vehicle types. Finally, battery electric vehicles rely entirely on stored electrical energy, utilizing systems like the battery management system and regenerative braking. Next, let's examine plug-in hybrid electric vehicles, or PHEVs. These vehicles feature an internal combustion engine, an electric motor, and a larger rechargeable battery that can be plugged into an external power source. Hybrid electric vehicles, or HEVs, combine a gasoline engine with an electric motor. Unlike plug-in models, these do not require external charging, as the battery is recharged through regenerative braking. Fuel cell electric vehicles, or FCEVs, are powered by hydrogen fuel cells. They generate electricity by combining hydrogen and oxygen, with water vapor as the only emission. Moving to Chapter 3, we will break down the core components across these various vehicle platforms. Battery electric vehicles rely on specialized components, such as the traction battery pack, electric motors, an onboard charger, and a dedicated thermal management system. Hybrid electric vehicles and plug-in hybrids include components like an internal combustion engine, a power split device, and fuel systems, in addition to their electric motors and batteries. Many components are shared across both EVs and hybrids, including high-voltage orange cabling, battery management systems, and specialized electric machines. Chapter 4 addresses the architecture of high-voltage systems within these modern vehicles. High-voltage architecture varies significantly, with EVs typically operating between 300 and 800 volts or higher, while HEVs generally operate in the 100 to 300 volt range. Safety interlocks are critical in these systems. The battery pack anatomy consists of interconnected modules and cells, maintained by liquid cooling loops and controlled by the battery management system to ensure safe operation. Chapter 5 explores drivetrain configurations and power flow. In a battery electric vehicle, power flows directly from the battery through the inverter to the motor, with a path available for energy recovery via regenerative braking. Hybrids utilize a power split device to manage the collaboration between the engine and electric motor, allowing for electric-only driving or combined engine assist mode. Plug-in hybrids offer added flexibility, operating in either electric-only mode or hybrid mode, depending on whether the vehicle is in a charge-depleting or charge-sustaining state. Finally, Chapter 6 covers the essentials of charging and energy management, which are crucial for maintaining vehicle health and efficiency. Now let's move to Chapter 7, charging levels. This covers the different ways to power an EV, including Level 1, 120 volts AC charging, Level 2, 240 volts AC charging, and DC fast charging, along with their respective connectors. Efficient energy management is vital. This includes using predictive energy control to optimize driving range, battery optimization, and advanced temperature management systems. Next, we explore the key design differences between electric vehicles and hybrids. Mechanically, EVs have a simplified drivetrain with no traditional engine, whereas hybrids rely on a complex integration of an internal combustion engine and an electric system. Electrically, BEVs typically utilize higher voltages and larger battery capacities compared to hybrids, which require additional energy routing between the engine and electric systems. Maintenance needs also differ. EVs have fewer moving parts and no oil changes, while hybrids require both ICE maintenance and specialized high-voltage system safety checks. Chapter 8 focuses on critical safety considerations when working with high-voltage vehicles. Safety is paramount. This includes strict adherence to personal protective equipment requirements, proper use of service disconnects, and following established lockout/tagout procedures. Regarding battery safety, it is essential to understand the basics of thermal runaway, the correct procedures for handling high-voltage components, and emergency protocols. In Chapter 9, we address diagnostics and troubleshooting techniques for modern electrified vehicles. For battery electric vehicles, diagnostics focus on identifying high-voltage isolation faults, interpreting battery management system warnings, and troubleshooting drive failures. Hybrid diagnostics involve analyzing the complex interaction between the internal combustion engine and the electric system, checking ECU communication, and addressing regeneration system faults. To wrap up, let's review the key takeaways from our overview of electric and hybrid fundamentals. Remember, vehicles are categorized by their propulsion, from battery-only BEVs to self-charging hybrids and plug-in models. Each has distinct component configurations and power flow architectures. Finally, prioritize high-voltage safety, understand your specific vehicle's maintenance needs, and always follow correct charging and thermal management practices for optimal vehicle health.